We're live.
All right, awesome. Way to go, man. Way to go. Here we go. All right.
Yeah.
Yay. So I'm going to call it the Papa Bale style motor.
Yeah. Because that's right up on the. And you said there's like a millimeter of clearance there.
Yeah, maybe you can see it. I'm not sure.
Oh yeah, there's. It's like a 16th of an inch.
Yeah. Phenomenal.
Yeah.
Perfect.
How's it going there?
Hey, there. What's up?
I like that.
Check this out, there. You got to see this. The millionaire. You have to see this. 12 volts in. Just gotta make sure it's 12 volts. Maybe a little less. Alright.
Oh wow. Look at the clearance here. That's amazing.
Alright, I'm gonna take a tack reading on this. 628.5. And then I'm gonna take one in 5 more seconds. And it's got a long acceleration phase. It's like 788.1.
Yeah.
We're generating set 180 AC volts off of this coil. Just one coil right here. $8.95.
Yeah, that's wow.
So smooth.
Yeah.
As soon as I figured out like the configuration and I had all these coils made already, and I just put them together, and it's like, wow, this is there's 4 transistors in this.
Hey Daniel, welcome to the channel.
Hello, hello. Let me check it real quick. Point 666, 665, 666 for AC ampage.
Yeah, that feels smooth.
Everything isn't bouncing around.
Yeah, and the shaft is stable.
We're 11.9 volts in and 0.6 amps. So we're getting a little bit more out than we're putting in, maybe. About equal.
Yeah.
That's the way it's supposed to be, I think.
Right. Hey everybody, welcome in. Thanks for dropping in. Let us know where you're from.
Yeah. We're from the D in Michigan, Detroit.
Yep.
Now, I have one more coil that I can actually, we space them out, put both of them right here.
Oops. There you are. Okay. And they're thin. They would be thinner.
No.
Oh, space them out differently. Sorry.
Yeah, so one with the fat one over there.
Yeah.
Because that one's got 22,000 turns of hand cranked 32 gauge, and this one has 18,000 turns of automated roll 32 gauge. This one is really tight. Really tight. The other one's kind of loose compared to this one.
This
It's
one,
got
right.
more in it, yeah.
Yeah, I remember how shaky it was too. This is like barely even moving a millimeter. It's pretty cool. Great work, Papa Bale.
Just a momentary burst of inspiration. All right. Power is now cut. We're at 0, over here, and this will go for 20 minutes. And it's due to the configuration of the coils and all the DC diodes I have in here.
That is wow.
So it doesn't really necessarily, it might make the rotor move, but it allows the rotor to move in that direction more easily. But I like to think that the coils are actually moving this thing on their own volition. You know what I'm saying? It's just, it can't last forever, but it can last for a while.
Yeah, I think the point of this experiment right now is to have nothing coming in on the input and see how much energy is stored within the system.
There's no actual like question that I asked myself. Like, well, actually, I did. I wanted to see how many volts I could generate, AC volts I could generate on this coil alone, and the answer was I could get 250 out of it. Gotta turn it up quite a ways though.
I think that's cool. That sometimes you're doing it just for fun, and sometimes you're doing it to figure something out.
Yeah. So if you look at it like a pastime, that like this here, for example, this coil and this coil are the same. They're 4-filer, 26 gauge, 200 turns, so they're 800 turns altogether. But this one is the same, but it's 24 gauge. Okay, so like I got so many different things that I was trying. I've blown so many transistors trying new stuff, and then I finally got a brand and like the power that I needed. Because I mean, this stuff is it's really heavy. Yeah, heck yeah. All 4 of them. Okay, so let me go through the circuit. You got this coil, power goes in here. Then it gets direct DC diode into this coil. And then it funnels through all 4 of its strands with an AC series connection to the transistor 3 times. So you got that 3 times. And then this coil right here is 250 turns of 16 gauge and then 500 turns of 26, which is 2 strands at 250 turns. And they're all linked together via DC diode. So this coil is like straight boom, boom, boom DC. And then the other ones you gotta pass it because they're like single file coil to multi-file coil.
Wow.
Yeah, so, but in my mind, effectively, they have the same effect, this coil and this coil combined, as this coil does.
Okay.
You know what I'm saying? Maybe even a greater effect. Because they were spaced out.
That's really cool.
See, when you get them all bunched up, the timing kind of gets screwed up. But when they're all spread out on the magnets, you know you're going to get at least 1 hit, if not more.
Hey, Lima, welcome to the channel. I think we've heard this before.
Oh man, I need really like sound containers for the Mercury.
All right.
Um, let me just, if you haven't seen it yet. And that's maglev. Yeah, I would do it, honestly, if I would have to print another rotor with compartments in it. And then the container for the Mercury would have to be, like I said, a sound container, and then I just put the container in the compartment and seal it up. You could do it like that.
Hey, everybody, welcome to the channel. Thank you for dropping in. Drop us a like, subscribe, leave us a comment, let us know where you're from.
Are we trying an off-balance wheel? Is that what we're trying to do? Like a Mercury and an off-balance wheel? Kind of like a Baccarat's wheel?
That's a good question.
Is that what we're looking for here?
Dare asked, do the transistors get warm?
They do not get warm unless they exceed the amp or the voltage rating, or they stop switching, and then they get really hot. But I should probably get one of those things for my phone that will allow me to see infrared, see the heat.
That's going fast.
200 volts. Yeah. 200 volts and yep, 666 AC amps. So 700 millivolts.
Not bad.
Milliamps. Oh,
There's the input.
here, let's get a reading on this. 1,000.
Oh, yeah.
Starting to get a little bit of a vibration. 1,000 is where it starts to shake a little bit. But it's just very tiny compared to what it would have been. That is fantastic. And I just pieced this all together last night.
I really like it.
Because before, it was just the 3 big coils without the quote-unquote pickup coils. Look at the difference. It's like, whoo! Dang. But also having the parallel circuit helps a bunch. So, yeah, that's good too.
So the parallel circuit is...
Basically having this one and this one times 3, so that's 3 transistors.
Mm-hmm.
And then this one coil over here has its own transistor.
Okay.
And nothing's hot. That's awesome. Everything's staying cool.
Ooh, Daniel, that's an interesting question.
I don't know. I guess.
Yeah, there's a lot of ways to measure, and
I haven't met it.
we don't, yeah,
Hold on a second. If possible. So a control to gauge the loss percentage of the weight wheels. What's a weight wheel? Is it this? Is it the rotor?
You're saying put an actual physical weight load on top of this?
Like well, I can't put any weight on it. I can put some, print some fan blades. We can push some wind. But no, the clearance this has on its maglev will not allow me to put any weight on it.
That clearance right there.
Yeah, see that's magnet clearance. But yes, I will print some fans.
Yeah.
Fan blades that we can as fixed like this. Maybe even glue on there. Just because I think it'll actually handle the load now. Hey, Peter.
Sorry
No.
to hear that, my man.
No.
Rest in peace, mommy. We were just love you, brother.
Yes.
Peace.
Peace, my man.
Oh yeah, you're talking about fan blades. Holy moly. All right. That's a shock moment of silence.
Yeah, really. That's unexpected. But yeah, man, I've been hearing more about having like a physical load on the brushless motor to see what kind of torque and stuff it has. So yeah, we'll work on that. What do you guys suggest? Like a three blades? Is 3 blades enough? I don't really know. I mean, I could make 9 blades, but or like an anti-force.
Hey everybody, welcome to the channel. Thank you for dropping in.
All right, so about the flux, however you say it. I know this thing looks ugly, but it's kind of powerful.
Thank you, David. We appreciate that. That was our moderator. Yeah, we're deeply.
Yeah.
But he encouraged us to keep going, and we appreciate that.
It's hard to know exactly what the right thing to do is at a time like this. But he suggested we keep going.
And he said he's going to be back stronger.
That's right.
Yes.
So.
And we're collaborating. Hopefully, we're going to be, yes, indeed, huge big hug that we'll be able to. Oh man, you did it!
Okay. So we're going to run this straight AC. We're not going to plug it into any DC. We're just going to cut a cord off of like some appliance, and we're going to plug it in to the end here, and we're going to see what AC current will do for spinning aluminum motor. Now I think this might be too much. This C clamp that I put it on, but this is 18 gauge and 14 gauge. And if you've ever wound those two together with your hands,
I get it.
like your thumb ends up getting kind of tired. So I mean, it's as close as I could get it to being uniform, but it's definitely not uniform. But I'm not sure that's exactly what matters in this instance. considering that we're going to be using static.
I think it looks all right. So I hear what you're saying though, that it takes up a lot of space with the thick wire.
Yeah, I think it's right around 25 turns, maybe 30 turns. So that's very, very, very short, thick wire. So I'm sure that the current that is going to be flowing through this thing is going to be massive.
Yeah.
Yes, we're making a what is it, an OTC X1?
That's what it is, yeah.
Yeah, Peter. That's for Peter, man. We're making that for Peter.
For Peter.
And this is going to be one of the things. I got PCB printing in Utron. We're going to start off with one. We're going to see what happens with that. We're going to hook it up to a Dremel. And we're going to spin it really fast, and we're going to see what kind of currents we can get from it. But all the readings that are going to be coming off the Utrons are going to be from visual or sensor. There's going to be no contact with this thing. So, I mean, like, we got to get some pretty sophisticated meters to read it, is what I'm trying to say. But yeah, let me get the rotor for this.
Hey everybody, welcome to the channel. Thanks for stopping in. Drop us a like, subscribe. Let us know where you're from in the comments.
So there's going to be 12 of these things. And you go around like this. Every other hole is going to be an aluminum plated, and then every other hole is going to be an Utron. Okay, and in the center is going to be an accumulator, which I'm hoping that I can just make out of aluminum wire. I'm hoping. But yes, if I can get the aluminum rotor to spin, that means this will work.
Hey, Aiming the Game, welcome to the channel. Have you ever wondered how many times you can twist your... What? Yeah. All right, you got anything productive? Okay. We got the moderator. I'm back to moderating, so I have to be on top of it.
What a question, man. It's like, I think I know who that was, too.
Oh, God. I'll get it.
Stop dosing on the fentanyl, you won't be twisting your balls. Alright, so let me show you what I'm plating it with. I wish that Utron was like ready, but this is 0.2 millimeters thick, so it's thicker than aluminum foil, and it'll go over every other hole. Top and the bottom, it'll wrap around, so like this, and then of course we'll push on the north and the south side.
Hey, man, we work in the lab, man. All right.
How would you know what my house looks like, dude?
So Daniel wants to know more about the Utrons. Okay. BLS, appreciate that very much. And he's even in on some of the let's get back to smiles. Yeah.
Yeah. It's a shame, man, because like some of these people that have the comments to say actually do have some pretty good input that we don't ever get to hear now, because
right.
It's like, yeah, I do. I clean it up ever so often.
There's a lot going on.
And it's all in one room. So, I mean, you just say clean your home. I got a big house. So, I mean, it's pretty clean.
You want me to bump him? Nah, we'll see. Oh, here we go.
I know you are. Wow.
Welcome to the channel, everybody. Thanks for dropping in. We got some interesting commenters coming through.
Yeah, man. It's like they don't understand what really matters in life.
Oh, of course not.
I'm not saying I do necessarily, but it isn't that.
Dude.
I know that. Alright, so I feel like I want to use this, but I know that if I touch this in the wrong way, it's going to kill me.
That's a bad angle. Can you tilt it? There we go. That's bad. No, bad angle. Tilt it down. Tilt it down.
Yeah, man, you're in the wrong spot.
Perfect.
There we go. Switch hands.
All right. That thing is beautiful.
Yeah, my kids love me. So I don't.
All right, let's go.
All right, where are we going?
Away from
Really,
trolls
I'm in
that are.
I'm in a natural lull in what's going on here, so I'm thinking about what's going to happen next.
Okay, welcome to the channel, everybody. Thank you for dropping in. Drop us a like, subscribe, leave us a comment. Let us know if you're interested in magnets, pulse motors, doing science at home.
I would love to do one of these, but I gotta take my time with it. Yeah, I can't have just. We'll get going on that though. It's a mini OTCX1. That's what it is. And that's Otis T. Carr, experimental UFO 1 or something. It's pretty cool. It's not only supposed to like reverse time, but it's supposed to I forget, like I think that's his main thing. It's like it's the space it travels through the ether. What I gathered from it.
Oh.
Which means it's everywhere all the time when it's actually functioning.
Thank you, Jerry. We appreciate that. BLS says yes, build it soon. I need to go back to 1974. Make some changes.
Oh yeah. Well, I see that's the thing. It's not a spacecraft, or it's not a craft. It's like 8 inches big. So I mean,
Can you send your consciousness back there?
send something back there.
Mm-hmm.
Maybe it just itself. Maybe it'll be the only thing that goes. Or it can like be a time capsule. For sure.
Here, yeah, read that one real quick.
Absolutely.
I knew you'd like that one, yeah.
So Sounds like, great Scott.
I'm gonna wipe the lens real quick,
Okay.
so just beware. It might, yeah, I think it's just the light.
And that was it.
Wow.
What a thrill, man. I'm telling you, that's twice in one day. The glue is no longer effective.
All right, so that's
That's scary.
it is when it happens, bro.
This thing was solid a second ago, guys. How many fell off? Just the one?
Yeah, I see just one.
So that was some quick responsiveness. Yeah, wow, dude. And that was completely recessed into the rotor. Wow. You all right? All right. Let's take a minute. That was pretty freaky.
Yeah, we do need a cage. Agreed.
Well, let me show you what all my new rotor designs. That was kind of part of my presentation. All my new rotor designs have individual cages for the magnets themselves. So they're actually in and held in place by the rotor now and not glued.
Yeah, though I do like the encased ones.
So that it's really quite a bit better. Wow. There we go. I did not think that was going to happen, honestly.
I did.
You did? Did you feel it?
Yeah. And you're just kind of letting it go at higher voltages.
Well, I was looking at it. I was watching it. Saw it happen.
What's up, Pfeffer?
Hey, what's up, my man? We just had a catastrophic meltdown.
We did.
I'm lucky nobody got. But see, I mean, we can laugh about it because nobody got hurt.
Right. Too many RPMs. That was the achievement.
See, now this one can go twice the RPMs and not have a single problem happen with the magnets. The only thing you got to worry about is this black one on the top coming off.
And I think we got some pretty good footage of it happening, so you guys can play it back a little bit and see if I actually did get it. Because the moment itself is a shock, but yeah, now we know not to be spinning any of those glued-in magnets that fast.
Yeah, man.
Like again, ever again.
Right. No, actually, the ones that are glued in like that, we're not going to use anymore.
Okay.
It's unfortunate, but it's the best way to go around making sure that doesn't happen again.
All right. But I do love your designs that use the forces themselves and or have an encasement.
Yeah, this one is a lot better.
What is there? Oh, it's on the flange. Okay.
Yeah, it's touching the flange. Ooh. All right, I just this coil, just chilling here, has 1.147K ohms.
Wow.
Over 1,000 ohms right here. So if you needed a resistor,
There it is.
yes sir. So like if you needed a resistor, you could use this coil instead.
I like that.
That was 1,000 ohms. I mean, it works. Or you could just use a little 1,000 ohm resistor. I mean,
Hey everybody, welcome to the channel. Thanks for dropping in. Drop us a like, subscribe. Let us know if you're doing any do-it-yourself projects at home.
man, and I had my 14-incher spinning so beautifully today, and the same thing happened. It just popped right out.
What do you use to design the 3D printed parts? It's like a CAD and then a slicer?
Tinkercad and create. I use the printer's software
Okay.
to slice it. And it's an Ender 3 version 3.
And it got the iron core. And then, welcome to the channel, Mike. Can you show me something that you think is amazing that's around you? Sure. This right here, my man. This is a gyroscope. Double, it rotates. Can you, hey Lucas, welcome
Hey.
to the channel. Can you, we don't have much background here, so what is AMBE? What is AMBE?
Enemy source power. I'm not sure. Yeah, what is that?
Yeah, printed this, yeah. And we're working on a version 2.0.
I'd love to get some sort of wireless apparatus to power it so that we could reduce the drag. It would work so much better.
Because yeah, with the wire, we'll get to this one in a little while. But it's beautiful. Yeah, thanks Mike, we appreciate that. Hey everybody, welcome to the channel.
Hey everybody.
Drop us a like, subscribe. You guys can backtrack in the live a little bit and watch
what happened.
watch a magnet fly out of a spinning rotor.
They're like literally like trebuchets, man.
Yeah, I know it hit something. It hit something.
Hit the
And that,
coil.
yeah, this was from one earlier. It broke this plastic thing. Oh yeah, it directly hit the coil. That's right, and that's what slowed it down. Then it just bounced off of one of these things.
Oh, dude.
Hey, Mr. Tim, welcome to the channel.
It's just that I can generate so much more electricity with the other rotor than this one.
That's what we're looking to do: generate electricity, get the rotor to spin faster. Multiple experiments, but in general, these are electromagnetism experiments with pulse motors.
That's awesome. I love saying that's awesome because it's awesome.
Dare asks, does a core increase the resistance of a coil?
I don't know. I know that it increases a lot of its qualities. It might. It seems like it is definitely increasing the resistance because that's over 1,000. And I think, oh, I don't know. It used to be like 400. That's what I remember, but I might be totally wrong about that now. I'm just glad nobody got hurt. We are so lucky. So lucky. Alright, we are almost done setting this up for a smaller rotor.
Okay.
What's up?
Thank you, Lucas, for explaining that. And that's so paraffin would be wax, right?
Yeah, paraffin.
But I really love the you know, using the elements themselves to generate, and if you can put them together correctly. But we would definitely love to learn more on that.
So, what I heard about the eddy currents is that you need a strong AC magnetic field. To move an aluminum rotor. Is that right?
Slows fast neutrons to thermal. So I don't think that was answering your question. Hey everybody, welcome to the channel. Thanks for dropping in.
Hey, what's up everyone? We're live.
Yeah, leave us a comment, let us know where you're from. If you're working with any do-it-yourself at home projects, electromagnetism or otherwise. I like how adaptable you are and how quickly you move on to the next.
Me?
Mm-hmm.
Alright, yeah, thanks man. Appreciate that. I just was real focused on what I was doing here.
I think it makes for good content.
Alright, just need to get our trigger coil. Let that dry a little bit more. Whew. Frick. Baba frick.
BLS.
Alright. Amen, brother.
That's still some pretty serious equipment, though, Lucas. Because you're working with active material. Well, I shouldn't say it like that. Um, but yeah, we appreciate it. Whoops, finger. I put my finger in
you might
front.
have some issue. I think, man, it's dark. That's my issue. I'm not sure everything's still
Plugged it. Yeah, that might have ripped a clip off for sure. Amps.
Amps, good.
Nice work, bro.
What voltage is it? 6?
6.
Right. We're gonna take our time breaking ourselves back into the higher voltages. That looks good though, for 6 volts.
Really good. Hey everybody, welcome to the channel. Drop us a like, subscribe, let us know what's on your mind. Leave us a comment, let us know where you're from.
Alright, and then this one is generating 66.7? No, 67 volts. Yeah, okay. At 5.99.2 N. So that's, oh,
Oh, can you do a tech reading on this one?
yeah. Now there's no maglev on this one.
All right, cool. Is that for
223.
commercial batteries, or are you just doing that on your own DIY? $233 VLS. That was 233.
Mm-hmm. Oh wow, that's different. That's real though. That's the real.
That is real. Yep. Let's get a 448. That's amazing.
Yeah, it's going virtually 450 at 2.5 watts. Or 3 watts.
That's right. Yep, 3 watt.
And we're getting 70 volts with the smaller magnets. And that's the only reason I was using the other rotor, because the magnets were so much bigger. You spin at the same speed and you're going to get way more out of it. Just sad I have to put it down. You know, it's such a good rotor. It was a good rotor. All right, let's see if we can do a 9-volt battery.
Coolio. Yodo and Lucas. I think Lucas said he's in Michigan.
Nice, awesome.
Well, we are also in Michigan.
So I'm also using not only the tach meter, but the voltage meter to demonstrate the voltage means the speed's increasing. If voltage is increasing.
Still going up. And I can feel it. I can feel. I don't know if it's the fan down here. Yeah, that was that fan. Never mind. Because there's nothing to blow wind off this thing. If there were some fan blades on there.
659.
Cool, yeah, we lived in Houghton Hancock for 15 years. We're down in Metro Detroit again, though.
Heck yeah, Lucas. Oh, it's in the morning. It's early in the morning. The days are kind of blending together. Me. 662.4.
Nice.
Bam, we're down with the sixes tonight.
Right?
So that's a nice, smooth ride, considering that it's not maglev. It's really awesome. I don't know, man. Yeah, we're brothers. So, right.
Let's see it. Yeah. Oh, was that rain?
Yeah.
There was, yeah, I mowed the lawn just in time. Woo!
The blinds are drawn, so it's cool. Alright, now 12-volt battery. Let's do it. So about an amp coming out of there. We'll say it's 12 watts. It's less than 12 watts, but we'll call it 12 watts.
Lucas said it was a joke.
Oh, I know.
And then how do I make an adjustable DC power supply for the filament of my X-ray tube? I think Peter might actually have some input on that.
Yeah.
Because nothing comes to my mind. Does anything come to your mind?
No. Is it about a 3D printer?
Adjustable DC power supply for the filament of my X-ray tube. So that's in the tube itself.
Oh, okay.
Different filament, yeah.
Different kind of filament.
He said I've already fried two. Yeah. And then Mike wants to know what are your goals?
My goals? I don't know. I do want to build that UFO. I want to build the Oscar T car X1. That's one of my goals at the moment. I usually don't set goals for myself. I usually just have if I have an impulse to make a coil or build a rotor, I just do it. And then if I seriously have to draw out a diagram of the motor before I build it, I will never build it.
I think it works out fine the way you're doing it.
This is how I roll.
Hey everybody, welcome to the channel. Thank you for dropping in.
800.
That's going 800 at a 12 volt now.
Yeah.
Yeah, you can definitely hear it.
it's never been more centered. That magnet is like dead center, I think.
That's true.
That's at least in its favor.
Yeah, I don't see any wobble on it.
$891. $893. You know what I could do? Is I can put some graphite powder on the flange so that it'll be nice and slippery for this thing.
Jeez, man. Superconductors. Have we looked into superconductors?
No, I've looked into vacuum containers though,
Okay.
and vacuum pumps, and trying to remove that kind of friction from rotation or whatever else. Oh yeah, that's awesome. What kind of effects you get, Lucas?
I think the switch got stuck.
Yeah, that's right. Good eye, bro. Oh, it's not the switch though, it's the contacts.
No, I remember right before we started filming, it was going and then it stopped. Because I think the switch, look, it really wants to go.
It does, that's what. Yeah, no, it's probably stuck though. You're right. Damn, if the reed switches were less finicky, this would be so much more like interesting. So I'm going to put one more in there for right now. So, I mean, this is the first thing I've actually built with interchangeable parts on the 3D printer. So, like, I can switch this reed switch out without having to take the whole thing apart, and that's awesome.
Nice.
See, I knew it worked.
Drop a like if you like this.
Heck yeah, man, this is the money right here. I think that's awesome, man. I'm just gonna leave it running at 45 volts. It's a power-hungry machine, but I love it.
Yeah.
And there it goes. Probably centrifugal force, broke the reed switch, or inertia. Because it's just kind of flapping in the wind right here. Yeah, I'll have to look at that later. Haven't had anything work for me very much for very long periods of time anymore. But I still consider that a success. That's a triumph. That works.
I agree.
And it does what it's supposed to do on its own, pretty much.
Hey everybody, welcome to the channel. Drop us a like, subscribe. Let us know if you got a passion for magnets.
Or electromagnets. Now this bad boy right here, I don't know.
Can't really tell.
Looking for a spark, yeah.
There we go.
It's a 14 gauge and 18 gauge wrapped around a C-clamp 30 times for a C-shaped electromagnet. Heck yeah. Alright, so I don't know, man. I wanna hook this up. I wanna see this work. That's what I wanna see. And as far as I can tell, in order for this to move aluminum, it has to have AC, strong AC currents moving through it. And I think with its length and the gauge, it's going to be strong whatever it is. So I'm happy with that. So, anybody have any ideas on how to get this moving? So this, it's a 6-inch disc of aluminum. Talk to me like I'm a small child with this stuff. I have no idea. So.
What's up,
Are you,
AA Ron?
are you talking about the hairpin motor, or is there a new motor in that?
Like the Hallback stuff? I think that, or no, that's
Cheers,
old stuff.
Aaron. UP? Looks like it might not even fit around this thing.
That shaft size.
Yeah.
Okay.
So I'm gonna have to get another shaft. I'm glad I have it too.
Welcome to the channel, Aaron. Thanks for dropping in. Thanks everybody for dropping in.
Really appreciate you guys. You keep me going. I've been watching this guy move aluminum really, really fast.
Nice work.
Yeah.
It's not gonna spin. Yeah, okay. So, graphite.
Nope. I'm gonna take this magnet.
Remove the toroid.
And probably some graphite powder.
The mallet.
Oh no, that's a pipe.
Yeah.
Oh, it's like that's that shit. Right.
Hey everybody, welcome to the channel. Thanks for dropping in. Trying to get this aluminum rotor onto the shaft right now.
There we go. Now, how do we hook up?
How do we make that spin?
Yeah, how to make that spin with electromagnetism?
Without magnets. Have you tried modifying an MOT to get higher currents?
What's an MOT, man?
Right. Maybe.
You gotta remember, I'm a small child when it comes. I've only been doing it for like a year and a half.
I mean, that sounds legit.
No, it doesn't matter whether it's legit. You just gotta say it so I get it, and then I'll be able to understand. But I don't know what an MOT is.
No, I know. We're still learning a lot of the jargon, Lucas.
And I want to know what you're saying. It sounds like it might work. Is it a transformer? A mini transformer? I only have a DC transformer. If if it is a transformer.
Hey, Ron in the house. Microwave oven transformer. Interesting. The cameraman might.
Microwave oven transformer. No.
Nope.
I've never scavenged anything.
So that Peter would definitely.
You might be able to get me one.
Yeah.
I mean, when the screw didn't come undone, I took a hammer to it, and it was that.
More of a brute force kind of.
Gotta get it open somehow. He said there was magic and wealth inside this thing, and I was like,
What
okay.
up, ghetto mining? This is a pulse motor, and it is going quick. And we got it plugged in. And we're working on trying to get this aluminum one over here to spin without any magnets in. You can't really see, but there's a line of magnets actually in this rotor here. Swap the secondary for the thick gauge wire.
You mean put it in the smaller one first? Swap those two?
Or with an MOT.
Oh, I see what you're saying. Manipulate the MOT.
Yeah, I think so.
Is that how he did it? Is that how Smile did it? I think that's how he says his name. Smile. Smial. He's really cool, man. And I've been watching him move these aluminum discs like nothing else. And I want to know how he wraps his coils. I didn't want to tell a secret or something.
Great question, Ghetto. I'll show you some. This happened earlier. This magnet flew out actually on this live stream. You can play it back and watch that happen.
Okay, can you induce it?
Another one on this one earlier today also. So we've been getting some power.
Can you induce it without the magnets? That's what I'm trying to do with the aluminum motor, is induce it without magnets. So it'd be strong magnetic induction without magnets.
Yeah, so we would need like coil, right?
Yeah, definitely a coil. But how to wrap it is what I'm wondering. Don't you need to cut the brake slots, force the disc to become polarized? Not to move it. No. Because you're doing all the polarization with the electromagnet. But maybe, I don't know, like, exactly how to answer that question, because it's a smooth aluminum disc, so I don't think you have to, like, notch it or anything.
Hey everybody, welcome to the channel. Thanks for dropping in. Drop us a like, subscribe if you like pulse motors and doing it at home. DIY.
It's weird, like and it might be hooked up to an MOT, I'm not sure. It's like it's oscillating between capacitors and the coil, and it's AC input, and they're like long bars of coil that he lies next to each other in an interval, and it ends up being, the combination you need to make it work. I wish I knew more. But like the north and the south, yes, eddy currents. That's exactly what we're trying to do. And yes, we are working with polarized electromagnets.
Yeah.
But how to create those electromagnets, the actual sauce to create those magnets, electromagnets, the winding structure, and all that stuff. I need to know that stuff. I'll make my own. And there's like caps involved. So like I said, oscillating caps. One, there's like north bars and south bars, and you got an oscillating cap for each north and south pole. Pretty much. And I'm pretty sure you do it just like you do it in the power supply over here. You decapitate one of these wires, it's a appliance or an extension cord. You get your AC connection, and you hook it up to wherever it needs to be hooked up to. I'm pretty sure it's a straight AC connection. There's no DC transfer. There's no power supply involved with this. Just thinking about it freaks me out because
I'm not sure what his name is.
Smail Blue Star, SMAIL Blue Star. And this thing, and it spins fast, man, but it's high frequency voltage. It's got to be 500 plus. So that, among other things, it has to be 500 hertz frequency at the start. So I don't know how to increase frequency. I have a signal generator, but I have no idea how to use it.
Hey everybody, welcome to the channel. Thanks for dropping in. Drop us a like, subscribe, leave us a comment, let us know where you're from.
Alright, like the Celtic cross rotor. This thing is mean. It'll spin nice and smooth. The magnets will not fly out. Like they're encased in here. All I need to do is maybe put a little piece of tape on there. It should be good. Dang, man. Yeah, so when I saw that that could be done, and I'm almost 100% positive he did not like stage this in any way. It's a annual flux motor, basically, with an aluminum rotor. So yeah, I mean, I know that the coil design to make this spin is going to be more of a flat design and not a radial design.
I'm gonna guess 0-volt swinger. Is that close?
No. Zener.
Ooh, Zener.
They tune themselves. Are they AC drivers? Oh, you mean to get the frequency higher? Ah.
High
Yeah.
frequency. Okay.
Yeah. Zin. Okay. All right.
Nice.
I'm gonna have to get a crash course on how to do this and not kill myself in the process. And I will wrap myself some coils and we will commence liftoff. That's awesome. And I say a lot more things than that's awesome. I do say that's awesome a lot because
Me too.
I think this is awesome.
$30
Yes.
kilovolt.
Yes, ghetto mining, absolutely. I think it would be great. Well, no, actually, the voltage has got to be around 50 or 60. That's weird. It's weird that he said that. He said that in his video. The voltage was like 50 or 60 and the frequency was 500. Really cool. I'm gonna stick around. I guess you have to have some knowledge of how to build any flux motor. Zero voltage switching, nice, bro.
Nice. All right.
Yes, zero voltage switching is what we're gonna need for the OCT. Yeah.
So any kind of, you want to try and do a contest? I don't know what we could like give as a prize. We could like pin somebody. I have no idea.
Okay, what would the rules be?
Guess RPMs?
Okay, and this.
Yeah. Yeah.
Alright, we're going to test people's vision skills. I'm going to turn it on.
Appreciate that, Ghetto.
And we're going to see who can guess the RPMs closest. Everybody ready? Here we go. Give it a couple minutes. A couple seconds. You can start guessing whatever you want, but it's going to speed up. I got 450.
We'll check them out. Wow, that is humming. My goodness.
All right, anybody else want to guess?
it's definitely going faster than when that first gas came in. So.
Yep. Anybody else? We got 450 from Ghetto. You want to make it? Oh, nice.
Welcome to the channel, Ross.
Ross. Beautiful. Let's check it. That's a good guess, I would say.
$888. Wow. Good eyes, Ross.
That's a beautiful guess, man.
Interesting. We clocked it in at 888. We'll do another. Another measure here in a minute. See if it's still speeding up. Yeah, that was really good, Ross. So I want to wind a rodent coil bigger than the disc. Ghetto working on a project. Somehow that makes sense. All right, let's get one more measurement.
Rodent coil. Yeah, I need to wrap a rodent coil as well.
Oh, yeah, that, well, we have, okay, so we're upper 8, around 900, yep. That would, it makes sense to have the coil itself be bigger than the disc that's rotating above it. If it's a 2D.
Yeah, I don't know.
Okay. We will look into that.
Yeah. I'm definitely looking to rodent coils more. I've wrapped a 32 point, I think. 2-dimensional.
All right. So that's pretty good.
Yeah, I've been up for 3 days.
Okay, so you're getting exhausted now.
Yeah.
You just let me know when we can go as long as you want.
Sweet. I want to get into something that I can continuously move forward with, that I don't have to have a bunch of patience to do. Like this OTC, my bad, OTCX1 is going to take a long time to get all the pieces together and everything that I need to build it, just so that it looks like what it's supposed to look like. Not to mention all the wiring that needs to happen. So, that's about the only one I want to do the nap for 3 days. I wish I could do that. I got kids. Yeah, man, they're not going to let that happen.
The kitties.
I wouldn't let that happen.
You said time for a nap. Oh, yeah.
Maybe 30 minutes. Well, I get some sleep tonight. That'll be great. And these transistors that I got rolling on these things are freaking awesome. And then they're best transistors I've ever had the privilege of using. They're NTE 2317s. Awesome transistors, man. And they go from like 500 volts and 15 amps. They're great.
There's one right there.
And yeah, so is there a way for me to increase frequency manually, like with the frequency, like a signal generator? And then, because it has frequency in it. It's really weird. I had this little tiny one, this little gray one, and I can increase frequency and duty cycle and all that on there. And it would actually have an impact on the energy flowing through my coils. Yeah, man, I need to probably call it.
You wanna take a break or you wanna call?
Like, what do you mean? Yeah.
I don't think we can pause lives, can we?
No. We can't pause the live stream.
Okay. Then yeah, see if anybody else has any
Go ahead.
any suggestions, like a VFD, voltage forwarding device. Is that right? There we go. You got it. Yeah, you got it. Yeah. If you're spent, let me know. We can call it.
Yeah, I'm pretty good. I was spent before we started. I think we did pretty good.
Yeah, review this one, guys, and you'll see a magnet flying out and just, kind of ripping right through our original setup, and then he had another one going within 5 minutes.
It was going so fast, guys, and the magnet just broke free of the glue and flew.
Yeah, and it nailed the coil that was right next to it, and it was loud.
It was like thunderclap.
And I think it's right here. Yeah, that one right there.
Those magnets are powerful, man. They're really, really powerful. Like when I first got them, if they came together, I couldn't get them apart with my hands. I needed to use a clamp and other tools to get it apart.
The variable frequency drive. Okay.
Cattle prod.
That's funny.
Hit him in the back, on the head.
Yeah, I just want to give a shout out to our moderator, Peter Holofac 2.0. You guys can drop by his channel, give him a follow.
Yeah, okay. Variable frequency drive. They are used to change the speed of motors. Yeah, I don't know. Maybe. I'll look into that. Variable frequency drive.
Because I think it's all, you can program these things.
Yeah, maybe an Arduino might help. But that's like a 5-volt thing. I don't know.
I guess, yeah, I was tired once, and then I touched a cat. Have a PC power
Yeah, I was tired one time. Many years ago.
supply. Yeah. I think I'm learning jargon in real time, which is good.
Yeah, man, and you need to help me because I want to figure out how to move the aluminum.
Okay, so it works with the frequency instead of voltage. Interesting.
Yes.
Yeah, that's something we're not doing.
I only need like 50 volts to make this work.
Mhm.
I don't need thousands of volts. I just need 50 in high frequency.
Oh. So the variable frequency.
But however, I do like to do things directly. Like instead of going through many different channels, I like to just take the most direct approach. So maybe 30,000 kilowatts of power or kilovolts.
I did get that one get out. Yep. That one I was.
Instead of the high frequency, what would happen? Like just jack the voltage up so high that, I mean, it would melt. What is going to be moving the aluminum disc is not your typical induction. It's all about eddy currents. So I know you're going to need a lot of current to get the eddy currents. So you need a lot of amps, a lot of current flow. That's why I use the big wires. In the bifilar coil. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Blast off!
So yeah, we're trying to get a live going every other day. Sometimes we're doing 2 days. And we definitely appreciate all the feedback from the community.
Yeah, I'm learning so much. This was a great live stream. Thank you very much for your input. It's very valuable to me. I'm learning a lot. Now I know that some of what's being presented is an idea, and that's good too. I like ideas.
Yeah. Ideas.
It's not necessarily a blueprint of how to build the thing, but it's like an idea.
That's right. Hook finger.
And a lot, like ideas, so many ideas. The gyroscope built behind Chris there, definitely an idea.
I'm definitely tired.
Yeah. Oh man, see, I'm about ready to pass out in the chair. So I think I'm going to tell everybody to have a good night, and see you next time. Thank you very much. Please subscribe. Bye now.
Thank you, thank you, thank you.